Hey, what's going on, guys? Welcome back to my channel and welcome to chapter 3 of the Cross Origin Resource Sharing course. In this chapter, I'm going to talk about the anatomy of an HTTP data exchange. I understand in the previous chapter, when we completed the same origin policy, I mentioned that we're going to dive right into the CORS policy. However, I would like to slot in this little concept which has a very big impact on a better understanding, of course. So basically, I'm going to do an introduction. I've added this sort of like table of contents here to guide me better and to guide us better. I'm already doing the introduction, and I'll talk about the client server model. I'll talk about the anatomy itself, stuff I want to talk about HTTP requests, basically the request, response, and the headers that go with it. And then I'll mention I'll talk something about the extensibility of HTTP. So the previous diagram we were using, this architectural diagram, we kept talking about servers and clients. We and the interactions between them within our client, backend, front end, and third-party APIs. And this is where our discussion was centered when we were talking about the overview and same origin policy. So one thing I wasn't really mentioning is that everything that is happening here is happening within the context of the HTTP protocol. So HTTP means hypertext transfer protocol. It's basically a protocol or a policy body that governs interactions between front ends and back ends, or clients and servers, as we've been seeing. It defines what a server is. All right, we're talking about a server serving all these resources, but what actually constitutes a server is defined by the HTTP protocol. Like what kind of configuration. So any computer can be a client or server, but then to turn a computer to give it the powers to be a server, you give it some capabilities or install some software. So an HTTP server is just basically a computer configured according to the protocol to serve resources. Then this is the client, or the front end we're talking about, is basically an HTTP client. Just like we've just said, here also, what makes a client is simply the existence of certain things. The most the most popular HTTP client is the browser, which I think most internet users, even right now, you must be watching this from a browser. So it's the most popular HTTP client on the internet. And then these arrows show messages going back and forth between the clients and the servers. And these messages are HTTP messages. Particularly, the client will send an HTTP request and the server will return an HTTP response. All right. So I just wanted to recap that within the context of the HTTP protocol, which we want to talk about now. And going back to this table of contents, that brings us to the other concept called the client server model. We this diagram is quite verbose and it has very many things. So I since we want to focus simply on the HTTP request response communications between clients and servers, I came up with a more simplified diagram. So what you're seeing here is basically a small network that of computers that is made up of clients and servers. So this is the HTTP has a concept called client server model. Basically, it's a model that helps us envision, I would say, 99% of the data exchanges that happen on the internet. So basically, it's just a model to envision. There's nothing else. And indeed, this is really what happens on the internet all day long. We have clients talking to servers, getting data, acting on that data, then sending back another request, perhaps, to the server. And these red lines basically show the data exchange. These I have a couple of clients here. And then the black boxes are servers. All right. So the internet is a huge, humongous network of billions of computers. Some of them are clients, some of them are servers, right? These computers serve their roles as either clients or servers and interact with each other all day long, every minute, every second, exchanging millions and billions of messages between them to serve users like you and I. So, this is what we do every time you pick your phone and you connect it to the internet. You've plugged into the World Wide Web, and your phone or your computer, which you connected to the internet, becomes a node in that network, right? And it gets a unique address, globally unique address to identify it. So this device you have can be able to send requests to other devices that are called servers. So the HTTP protocol governs all these things we see here, all right? It governs the definition of a client. What really is a client, as we saw earlier? And I said the most popular client on the internet is the web browser. Most of us use it every day. And then I also want to mention that to be a client, you don't have to have a browser, all right? Or you don't have to operate from a mobile client, a web app, a mobile app, like an Android app or an iOS app. A server could become a client as well. So for a server to become a client, it can communicate with fellow servers simply by formulating appropriate. It needs to understand the HTTP protocol from from the perception of a normal browser client, right? It needs to know how to formulate a request that will be understood by the server, that will be transported over HTTP successfully, and will be understood by the server. And the server will send back a response. And this server that is now acting as a client, just like our client six, should be able to process the response and decide accordingly. Definitely, there will be differences in the kind of messages that browser-based clients can send and receive, uh, as server-based clients can send and receive. For example, browser-based clients may be able to process HTML responses, but server-based clients may prefer like JSON or XML responses, right? So we've looked at the server, and basically the HTTP protocol dictates what a server is, as we mentioned, and it dictates according to its dictates. Then a server usually needs to have a specific kind of software or a certain kind of process running on it. This process has unique capabilities. It doesn't have to be the only software running, but in most cases, this is what is happening on the web now. But it doesn't have to be the only software running on the server. The server could have other kind of software running, but at least at a bare minimum, there should be something called a server software. Examples of these are Apache Tomcat, Apache HTTP, and then we have Nginx, very popular server. So when that software is installed on the server, it starts running, then it can serve resources over HTTP. All right, it can receive requests from clients and then locate which specific service running inside it can serve that request. And then on the client side, you also need to have specific kind of software running on it to be able to be called an HTTP client. Okay, like I said, the most common is the browser, and basically these red lines show data exchanges. Typically, the client will formulate a message, send it to the server. The server processes it, formulates a response, sends it back as an answer. And even the exact format of this message that the client formulates must meet certain guidelines by HTTP protocol. And it's usually called an HTTP request. And then what the server sends back is called an HTTP response. So the internet in most cases is just a couple of HTTP servers and a couple of HTTP clients interacting with each other by formulating HTTP requests and processing HTTP responses. So basically, that is the power of HTTP protocol. And now I want to take a look a little bit. Okay, we've talked about the client server model. we've really talked a bit about the HTTP request, HTTP response. We've not talked about HTTP headers. So I have another diagram here that shows a specific and concrete example of an HTTP request from a client going to a server and a response the server sends back. So on this side, I don't know if it's on your left or right, but on my left there is request. On my right there is response. So what is an HTTP request? An HTTP request is simply a data object, just a set of fields that are fed into the HTTP client to be able to send to a server. In an HTTP request, typically we have what we call the HTTP method. The HTTP method is just usually it's like an enum of values. The HTTP methods is an enum of values that are specific and can be understood by both client and server. So these methods are typically verbs like post, put, get, delete. And then there are others which are nouns like options or head, and they communicate the intent of the client in sending that message to the head to the server. For example, post is just the client saying, "Okay, I'm sending you this message. I need to make some changes on the server to specific data." All right. Get would mean that the client is just trying to query data and nothing else. It doesn't expect to leave any changes. It doesn't expect to change the state of the server. And then delete does what it does. It will change state on the data on the server and remove some data. And then put is for updating. Others like options and head typically just they have other unique purpose, but we shall not discuss it here. Another field of the request is the path on the server. Remember, in the overview of web applications, we talked about URLs. Even in same origin policy, we talked about what an origin is, and we discussed. You saw some URLs or web addresses that have path. You know, maybe facebook.com/en slash something, and then some query parameters. So basically, the path is just the path parameters of a URL. So, for example, if your address is at localhost port 8080 slash admin, then up next to post would have a slash admin. And then next we have the version of the HTTP protocol the browser is using or the client is using. Now, something else we didn't mention is we talked about request response. We didn't talk about a certain part of the request and response, which is the headers. So headers is very critical for our purposes in this lecture. HTTP headers are basically uh, key value pairs of fields that we attach to HTTP requests, they are not really directly impacting the request, but they are like metadata. They offer extra instructions. They add extra functionality and features to this how this request should be handled. When a server sees a certain value of a header, it may know what to do differently from what it would have done if there was no such field. Just like a client will decide some things based on the values in the header that is in the response. So both requests and responses can have HTTP headers. So for example, let's look at some of the headers here. In our request, there's a header called host, the value localhost 8000. Basically, what it's saying is that the client is quoting the host that is containing the server application that it wants to communicate with. So in this case, our backend application is running at localhost port 8000. So this alone is not critical in the request, but it may be used for something. Like I said, it depends on the use cases the developers would like to take advantage of. But we have a host header, we also have a user agent header here. So basically, this is the software, the client software that the user is using, including the computer, the kind of computer it's using to send requests to the server. So in this case, our request is coming from Mozilla. The computer is a Mac, and then the browser version. And then the accept header basically communicates to the server that the client can only process a certain kind of request types. For example, here the client is saying I can accept text slash HTML or XHTML, right, and XML. Then accept language is similar. It means that the browser is running a certain language. These are very important fields. They don't really impact the processing on the server. It just impacts how the server, what additional information the client would like to tell the server, and the server might be able to action on it accordingly, depending on its capabilities. For example, the server may not be having any capability to do anything about the language, all right, but some may, maybe for internationalization purposes. Other internationalization, I mean, providing the service on the browser in different languages, depending on where you're located and where and what you've selected as your default language. And then the connection header simply means that the client is telling. So typically in an HTTP exchange, the client will establish a connection with the server in a couple of interactions. And when the connection is confirmed to be established, then it sends the message and gets the response. So then that is done. However, when you say connection should be keep alive, it means the client is telling the browser, the client is telling the server that when we establish this connection, please keep it open for future requests. This is just an optimization technique because establishing a connection is a very expensive operation. All right, so there's a couple of more here, like the content length header. It's simply the client saying, okay, the content I'm sending to you has this length in terms of bytes. And then typically there's the body of the HTTP request. All right, the body, maybe you're saving some data on the server and you add a JSON object with the details of the data you're sending, maybe a user's biodata, and so it forms part of the HTTP request. Then coming to the server, the response side, again we have protocol version. Then we have the HTTP status. So HTTP status is another clause in the HTTP protocol for communicating the status of a request the client sent. Did it succeed? Did it fail? If it failed, why did it fail? Is it a problem on the client side? Is it a problem on the server side? So HTTP protocol defines a certain range of status codes, which are integer values. I think between 100 and maybe 1,000. I don't know, maybe around 500 something. Basically, for those that are used to the internet, status, these are hidden from the user, but developers would know. So status 200 to maybe under 300 is a success status, means the request passed successfully. The status 300 to under 400, maybe it was successful, but the response is not a straight response. I don't even know how I'm saying that, but the most common range 300 status code is 302. It means it's a redirect. The server sent a response, but it's a redirect. It's instructing the client to move to another web page. So then status range from 400 to under 500 means that the user has needs to update their request. Something is wrong with their request. For example, here we have status 403. And then there's the status message. I hadn't talked about that, but status 403 means that the request is forbidden for the client by the server. So since it's the range 400, you can a developer can tell that the problem is on my side. Maybe I need to add an authorization header, or maybe I need to update it, or my cookies are expired, whatever the case. So then status 500 range is basically meaning that the server is saying, I got your request, it's really legitimate and it's good, but I've failed to process it. Maybe you can try again later, or you can contact my administrator. All right. So then the rest are HTTP headers for the response. So after the server receives the request, it will also send the response with a set of headers to communicate some things it also wants the client to do with this request. All right, or additional metadata, as we said. Okay, so the server may decide to add a header as a response to a certain header the client added in the request. So for example, the client had added connection header, keep alive. The server responds with connection keep alive. That means it's positive. It has accepted to keep the connection alive. And then it adds an additional header, keep alive. Timeout is 5 maybe seconds. And additional information, additional instructions. All right. And then there's another one here, content length, the length of what the data the server is sending back in the response body. And then date and all content type the server is sending. You can see it's the same type, similar type that because the client had said, I accept these content types. Then the server responded with text HTML, one of them, which means that, okay, this is what I can offer. All right. If the content type was not something the server could provide, then there would have been a different response. Okay. So as you can see, this HTTP protocol just provides also a contract, an understanding between clients and servers to have seamless communications, to understand each other. When I say this is what I mean. When I add this header, this is what I mean, and this is what I want you to do, so that we work together. Okay. So then the HTTP response also has a body over here. Okay. So that is basically what happens during an HTTP request response between clients and servers. In a nutshell, it's more complicated than this, I think. We can go several levels deeper, but this suffices for our purposes. So going back to our table of contents here. So one could say we've covered request, response, and headers. Then the really, really important point that brings it all together for us before we proceed to cross-origin resource sharing is the extensibility of HTTP. So for any modern framework or software or system, any engineering system, for it to be really valuable and sustainable, it needs to be extensible. Something which is black box and really rigid, and the users cannot add additional capabilities to it, is not going to last very long unless if it offers value that is really beyond the capacity of any competition. But there will be competition that has features that are make it extensible. Browsers are extensible, but you can add plugins in browsers and improve their capability to suit your needs. All right. Most software extensibility is a big value in building software, both backend and front end. You want developers to be able to extend the behavior in a smart way without breaking other features, without changing the core features of the application. So here as well, HTTP protocol as a set of rules governing communication on the internet is extensible. And we've already seen a bit of that extensibility. And its main point of extension, you can add more capabilities to the HTTP protocol by adding additional headers. What does it mean to add an additional header? You don't need to change any software. You just have a header that the server that's going to process the requests can understand and the clients can understand. When you specify a certain new header that is not among the standard headers the HTTP protocol defines, then you are adding a premise for new behavior. So maybe you can add a header like X uh, session ID or X something. Okay, really the name is arbitrary. It doesn't really matter. But the point is, you want to add a new header in your HTTP interactions, and the server has capability to handle that header. The client also has capability to interpret that header, and then you will have added additional metadata that the clients and servers can use to enrich the feature set you want to provide. So, for example, the authorization header, which is pretty common in security, is just an extension of core HTTP. Basically, when the server sees the authorization header, a server that has security capability should be able to know, okay, when I see this header, this is what I should do. When I don't see it, this is what I should do. A client, when it sees a header, maybe a new header, then it will know this is what I should do about this request or this response. Okay, so having said that, uh, basically, the reason I wanted to cover this topic is because cross-origin resource sharing is basically just an extension of HTTP 1.1, right? It is an extension, additional capability on top of HTTP. And we've already said that adding capability to HTTP protocol simply involves something as simple as adding new headers and building a shared understanding of what to do when we see these headers in requests. So you'll find, so there's one field that the CORS specification added to the HTTP protocol. So the field, the header origin. Okay, we've just talked about same origin policy. So the CORS policy adds a new header that can be understood by both browsers and servers. The new header is called origin. So it means that since CORS is a policy, a specification to help us relax the same origin policy, how does it do it? So after it went into effect, it now demands all browsers to add a new header in their request called origin. The origin contains the origin, as you can see, the source of the script that's making that request. For example, if you downloaded a script from this site and this script is making a request to that server, then the script is dictated upon, is mandated by the course specification to add. The browser is mandated to add an origin field, an origin header in the request, and the origin should point to the origin of that script. All right. So this is very important. CORS is an extension of HTTP 1.1. It extends HTTP by adding a new header called origin and mandating all CORS compliant browsers to add this origin in the request. The presence of that origin alone is just, it's the simplest implementation of the CORS specification. Now, when we talk about CORS, we are now going to see, okay, after browsers add this origin, what do servers do? How do they respond? And which other additional headers do browsers add? And which headers do servers add to be able to communicate with their clients in browsers? And how do they enforce the CORS policy? All right, so that is what I wanted to highlight, and I hope really you see the connection between why I wanted to cover this and an understanding of the course specification. So in the next video, we're going to finally go into course and we'll talk about all these headers. And remember, course cross-origin resource sharing is defined as a header-based specification. Header-based because it completely happens through headers. It's not core to the request you're sending. But as we said, headers are just metadata to enrich the interaction between clients and servers, to add additional information to help in processing, to help both the client and the server in processing. So the request is completely separate, but it will determine whether the server will accept that different origin request or the browser will accept to send it. These additional headers are interpreted by both servers and clients, and they are implemented in a way to enforce the cross-origin resource sharing specification. So let's roll to the next chapter, and I'll be seeing you over there. Thank you. Cheers.